Let's see, the time is 9:59 a.m., which is close enough to 10 o'clock for me. The date is February 8th, 2019. This is the regularly scheduled meeting of ITSE 2309, which is database programming with SQL. And I guess I can take this off. I'm not going to start my video today. There's no real reason I need to waste the bandwidth. You know what I look like, or if you don't, good for you. Let's see. A couple of matters that I want to start off with. First thing is I guess there are some artifacts around where it may have said at some place in the modules to name your database like jdoe_db or something like that. And I wanted to change that, and I want it to say, I want your database to be named, please, Scratch DB. Okay, so if you got a message from me, if you turned in something and it didn't say Scratch DB, I didn't take off this time, but I will. If we're all naming our databases something different, then it's going to be a real mess. Therefore, we need to decide what they're going to be. Well, I've decided I'm going to name them Scratch. Last semester we named them everything, and as work came in, I would have to change it. And it was a pain in the neck, so we're going to name it Scratch. Now, if you have named it something else, do not despair. Okay, here's what you do. Watch what I do here. I'm going to connect. Now, one way to connect is just go up here and click this icon, the little plug-in thing. It says connect. Notice that I am connected. Whether I am or not, that's fine. I don't have to be. I'll connect. And I'm going to connect using Windows authentication. Windows authentication, because I want to come in as this system administrator. I could also log in as SA. But if I connect with Windows administration, I don't have to have a password. So I just connect Windows authentication. Under databases, I'm going to right click and go new database. Now, I already have a database named ScratchDB, but you'll then Scratch, SCRATCH_DB. The owner will be your user. In my case, it would be SW Smith. I don't care. You can be the owner can be you. But I want the database named ScratchDB, please, because I will have one. I already have one named ScratchDB. So when yours comes in and you're using a database named ScratchDB, I'm already going to have that one named. Do not say add. If you say add, what happens is you add another row for this. So these are the database files. These are where your database will be stored on the disk. You don't have to worry about them. If you care about them, you may look at them. So there's a anyway, we're going to talk more about this in the administration portion of it, where the files are and all of that. When you are finished, you would just click OK. Since I already have one named ScratchDB, I'm going to go ahead and cancel. And now I will go to the Security tab and to the logins, and I will select my login. I will go to the properties of my login, okay? And I will make the default database be ScratchDB. From whatever it was, make it be ScratchDB. And then say, okay. And now everything is fixed. You can let's see, deleting the other database. Before you can delete a database, drop him down, and you have to, if I wanted to delete this database, first thing, I have to be the system administrator. I have to be the system administrator. So I'm talking about one that you may have created that you don't want anymore. It's not a big deal if you just leave it, but if you right-click and go to tasks, you have to take the database offline first. Take offline, then there should be a delete option here. After you take it offline, if you right-click, one of your options is delete. And it will, but you have to be the system administrator. You can't do that as your general user. So I'm done with that. I'll connect now. I am connecting as SQL Server authentication, and I connect as SW Smith, or you would connect as yourself. And now when I run a script, static, okay. Let's see, SDB13, your microphone is hot.
Oh, sorry.
Yeah, it's okay.
Sorry.
I can mute it. I just, there you go. Yeah, we generally run with them turned off. I know. Okay, where was I? We can, now I'm ready to go. I wanted to talk, let's see. Wanted to talk about the, we were creating a database with owners and pets, I believe. And let me open. I sent you these files. Begin to create, so yours should say use ScratchDB. We're gonna, if we need to have this, if object ID pets is not null, drop table pets. So you're gonna see this kind of thing happen over and over again. Let's see, I didn't mean to open that one. That's the answers. That's okay. Let me open a file. Okay, this one uses doctors and patients, and there's just a gazillion of these. It's a parent-child relationship. I could do pets and owners. I can do cars and manuals. A car has many manuals. A manual references just one car. Golly gosh darn, cars, passengers, aircraft and passengers, all kinds of things, one-to-many relationships. Anytime you see a one-to-many relationship, so that doctors and patients, so the patient, many patients, one doctor has many patients. What happens is that the primary key of the one side, in this case the doctors, the primary key of the one side, and this is the thing I want you to get out of this whole lecture, gets copied over into the many side. I say it always keeps its name. Always? Well, maybe not always, but it must be the same type. So char 9. Maybe not always keeps the same name, but it sure is a lot less confusing if it does. It comes over as a foreign key. Okay. Now, the child table is dropped first. If I dropped the child table, that would give me invalid references. The only thing when I create this foreign key here, the only thing I'm saying is that if you have a value in this DSSN field, that value must appear in the doctor's table, in the parent table. Okay. So if I dropped the parent first, I would have an invalid reference in the child, so it's not going to let me do that. The child gets dropped first. Drop the child, then drop the parent. Then create the parent. Then create the child. Questions? Now, today we're going to look at, let's see, was there anything else I wanted to say about that? Biggest thing, my biggest bug today is the name of the database. About half the class, I was taking off a point and then I realized, gee, I'm going to half the class isn't going to get it. So I wanted to cover this. Go fix your database, and then everything will be fine. Okay, we're going to insert data. If I've created the doctors, created the patients in that order, it makes sense that I have to insert the fields into the doctor first. I don't have to insert all of them. But before I can use this value of what is that 447458999 in as a foreign key, it has to exist in the doctor's table. So now I can put this one into the child table. So insert into doctors. Now this is the field list, and it is, you don't have to have a field list. If you don't, you'll see people will write code without it. Insert into doctors values, and then they just put the values there. And in that case, that requires you to know what order they were created in, but you might not know that. You might not have this. So maybe all you'll know is the names of them. So most of the time we use the field list. Now I believe they're in that order. So this is the order they were created in. So this would be the default order if I didn't provide one. But I always use a field list. So always insert into doctors, and then it will always have a field list. I'm going to talk a little bit more about that in a second. We're going to have a whole module on this. And the values. Now, this list doesn't have to be in the order that they were created. It can be in any order. It's just that the values must match. This first value matches the first field. The second value will go to the second field name, third to the third, fourth to the fourth, fifth to the fifth, and so on until you run out. They must have the same number of values. Well, no, they don't. For example, if I did not have a city, I could leave it blank, but I would have to have, it would have to look like this. Well, it's not, it's giving that a red flag on that, so I guess it doesn't like it. And some of them, you can have an empty comma, comma in there. I guess you can't in SQL Server. I'm going to talk more about that little red mark that it gave me here in just a second. Questions on that. So this is just a plain insert. I'm not going to drag this out too long today. This is how you insert data using SQL. Pausing for a question. Very well, I will go on. You can also stack them up like this. As you get into further programming, you're going to find that this will not be real desirable. And the reason being, well, I'm not going to go into the reason, but there are reasons why this is better than this. And you'll get that next semester or if you take the advanced class. It tends to lend itself better to a higher level program. So, and copy and paste is my friend. If I copy this and just paste in my values, it doesn't really save me much typing because Control C, Control V, and I copy this and paste it a bunch of times, and then I just put in the values. It doesn't really save me much typing to do it this way. Note that the end of the lines on this one, there's commas separating these guys. I can have 50 of them there if I want, and then the last one ends in a semicolon. Personally, I would just type 50 of these, or not type it, I would copy and paste 50 of these and then put my values in there. I would just have empty values and I would just add in the values. You can also create this. You can output this from a C or a Java file into a file and then run it. Lots of things you can do to speed it up if you're reading it from a file. I usually go, that goes to your C programming, but I could create this. I could create a file with these in it and then run that just fine. So you can do it this way. I don't necessarily recommend doing it this way, but the book shows you that you can, so I'll let you do that. Supports fewer than all fields. For example, insert into doctors, DSSN, DNAME. I must have at least these. And the question is, why must I have at least these? I must have DSSN. I must have DNAME. But care to take a stab at why? I do invite your participation.
Constraints are required fields.
Yeah, they're required by the constraints. The primary key requires that I have a doctor's PK or DSSN, and then this one requires that the DNAME not be null. The rest of them are going to be null, but that's fine. The only two that cannot be null are these two. So a minimal set would be SSN and a name. By the way, I believe the name, there is one little issue with not null. This, the quote, is not null. That is the string with 0 characters. So it says you have to have a name, but your name might not have any characters in it. And that is a problem that database has. You probably remember it from your Access class. One of your check boxes down there is allow 0 length. And I think that by default they should not, but anyway. But this, all of the other fields will just be null in this one. So since this...
Could you write that into the constraint where it limits it, or it requires a length of at least 4 for the name?
Yes. Usually you write it, the length has to be greater than 0 so that something is there that you can see. Other things you can do, you can give it a default value. I haven't talked a lot about that, but in the for example, in this one, I could give it a default, and so if you didn't provide something, it would get that. But yes, you could certainly write it into the constraints and require a length greater than 0. And in fact, I typically do that. It's a good idea. I want to see something in there. Okay. So if it can't be null, then isn't it important that it have at least 1 character in it? But if it doesn't have any characters, that is not null. Populate the child table. Okay, I have a doctor up there. I have a doctor that has this foreign key, 447198765, and I believe that is the doctor named Charlie has that. So we're going to be using Charlie as our example. So insert into the patients this. Let me run this. By the way, it allows you to run pieces of your code, and that is okay. So I run the pieces. If I do Control R, I close that that window down there, and then this will let me insert some fields. So I'll insert Bill and Charlie. Notice it says 2 rows affected. That's going to cause a problem later in another class. That 2 rows versus 1 row inserted will cause a problem in a later class. It won't give you any trouble here. That's fine. If you do it this way, I'm fine with it, but just remember that probably you're better off doing it like this. So now I can insert into the patients table. I can insert Joe, and Joe lives up here with me in Denton, and the doctor's social security number is 447198765. If that did not exist, I would get an error, but when I execute that, it does accept it. If I were to change it, I can change I'll change his patient ID, and I will do something. Now the doctor's ID is bogus. When I try to insert that, I get that it conflicted. Notice that I see the foreign key constraint in my output, but it rejected it. Let's see, what was that? Charlie, what was your? Now it would accept it. I think he was 5'4". I can test it, try it. That should, well, it accepted it. Oh well. Okay, I can also I can insert another one, so Kevin can also be. Notice that the doctor's social security number is the same. This is the idea one to many. Joe and Kevin are patients of Charlie. Insert into it. Notice that this one, I'm inserting a null value for the doctor. I could have just left it out of the values field altogether, but here I'm explicitly saying I want to put a null in there. If I execute that, it works. A foreign key can be null just by default. If you just make a foreign key, that foreign key can be null, and we call that an orphan record. It has no parent. It doesn't hurt the database. Now, it might hurt what you're trying to do with the database. Do you really want a customer in your database that has no sales rep? I don't know. That's up to you. Now, if I put a constraint in there into the patients table, and I said the constraint check that the DSSN in the patients table is not null, then you would not be able to put a null value in there. But it's a different constraint. It's two constraints. One that creates the foreign key, one that checks for not null. I'm going to pause here for questions.
Can you point the insert command to a file instead of just having to type out the values? So if it was like a CSV file and load it?
Can you do that? No, not in SQL you can't. What you would do with that if you have a CSV, the question is about a CSV file, comma separated values. So I have a whole huge file, or I have taken a spreadsheet that's got about a gazillion lines in it, saved it with comma separated values. In other words, I have text in there. What I would probably do with that, I would go in with another programming language. I personally would use C. Other people use Perl, works very well for this. Other languages exist that will do it. You open that file in your other language. Python, for example, will work really nicely here. Open the file. Read a line of the, read 1, 2, 3, 4, 5, 6 values in it. Then you print to another file. You print insert into patients with this, print that line, and then print values, and close your parentheses, and then add these guys with the commas between them, close the parentheses, put the semicolon, move to your next line. And so you just write a end of file loop. In other words, you convert it to SQL. Now execute that. I hear somebody speaking. Who's talking to me? Okay. Well, nobody's turned on their microphone. Okay, did I cover that question? I hope. In SQL, there is not a tool. Now, in the database platform, there probably is a tool. It's probably in the graphical user part of the database platform. And yes, I'm sure that the tool exists, but it's not part of SQL.
Okay, thanks.
Okay, let's go to update then. Oh, I wanted to cover one other thing. This guy right here, go. The go command is frequently grossly overused. It doesn't really hurt anything if you have go and you didn't need a go at this point anyway. what Go does, it breaks your code up into two different batches. So for example, if I get an error up here, right, it will abort that down to here, but then it'll try to execute this. So the Go breaks this into two different batches, and if it aborts, it won't necessarily abort the whole thing, which may or may not be a good thing. The other thing it does, it makes sure everything happens before we go on. Now, where do you use a Go? I'm going to tell you, some people will just put them everywhere between each statement, and I guess you can. It doesn't really hurt anything. Well, where do you need one? You need one after you have created the table. So create table, you can use it after each create. Certainly after you have created your tables, plural, you should have a Go before you start inserting, because make sure all of this has happened and then insert. So it just it kind of says it's similar to what you would call a commit. In other words, make sure all that has finished and then start a new program. You don't have to put it between each statement. Generally speaking, you put it after a create. After a create is where you need a Go. I usually put it before any creates. We're going to see other things we're going to create where we'll have to have a Go. For right now, you don't really need to put one every place. Okay. Notice I didn't put one here. I don't need one here. Update. Update patients set DSSN is equal to that, where the patient SSN is this. In other words, I'm taking care of Dale, I believe. 44712. No, where do I have null? Okay, here it is. The patient named Lime, L-I-A-M, Liam, I think, has no doctor, so I'm taking care of that. So, in other words, where the patient SSN is this. For updates, I far prefer the primary key of my target table, but I don't have to. I could say update it where the state is Texas, and then it would update a bunch of them. So I don't have to update it one at a time. So set the Dr. SSN, so I'm adding the Dr. SSN into this. Questions there. Updates will let you, by the way, you got to be really, really, really careful here. What would happen if I just executed that? Update patients, set DSSN equals 447, whatever that is. What do you think would happen? That is a question.
Would it set everybody to that?
Okay. A couple of you hitting each other there, but that's fine. I heard the right answer in that. It would get them all. And you would. SQL is not a forgiving language. We have a saying in computer science, error messages are your friends. And SQL is not known for being friendly. SQL will wipe out your whole database very quickly. So you know that we have another saying, have you hugged your backup today? Yes, there are ways to make it more friendly. There's several reasons why it isn't. Why don't you have an undo capability on a database? And the answer goes to just the size of the database. The fact that the database lives on the disk, not in memory. So if I'm in word processor and I make a mistake and I say, okay, undo, all I'm doing is changing memory. So I have to keep a track of all those changes. What was it before I made it like it is now? So I have to keep track of that stuff. There's a limit to how far you can undo backwards for anything, whether it's a spreadsheet or a word processor document. With a database, though, you're typically doing so much stuff at one time that undo. You just don't have the luxury of making a copy of the database, because the database is typically several million rows. And you don't have the luxury of working in memory. Therefore, it's you typically have a backup of tape. But if you make a mistake, it can easily take you 2 or 3 hours to bring it back to the state where it was. And of course, that would make Amazon.com real happy if you shut their database down for 2 or 3 hours. Wouldn't that? That would be called a resume generating moment. In other words, you're going to get fired. Update. We're not going to do a whole lot with update. Delete, about the same thing. Delete from patients where SSN is equal to this. We have to delete the child first. We have to delete the patient first. Then we can delete the parent key. You saw that when I created these guys up here, I have this if logic in there. By the way, this is not SQL. This is not SQL. SQL will always have wrapped around it a iterative language, and in that language you will have if then else, you will have while loops, you will be able to create variables, assign variables, and that's what the next class is about. So don't worry about that for right now, but this is just an example coming from the next class. This one says if it exists, then drop it. But if it doesn't exist, don't worry about it. And I usually will tab over under it. Okay, I do want you to put this in there. Right now, it's just kind of like, okay, that's the way we put it in there. So we drop the child table first, then we drop the parent table, and we have the if in there, because if we just said drop table patients and patients didn't exist, SQL throws an error, and then your script aborts, which isn't fun. So we have that in there to suppress the error. If you just had drop table patients, then you would have to highlight the create table doctors and run it first. Now, where was I? So delete the child first. If I tried to delete the doctors, so delete from doctors where SSN is 447, that I believe that's Charlie. I think 765 is Charlie. If I tried to delete Charlie without deleting the children, I'm going to get this error message. It conflicts with the references. Notice that I'm not sure what kind of, some of them have better error messages than others. SQL Server has pretty good error messages. If you get into Oracle, their error messages are very cryptic, but I'm guaranteed that I will see this error message if I have named the constraints. So that is why I insist that we always, instead of just saying primary key after the PSSN, we will always name the constraints like this. The other thing that I can do if I name the constraint is I can have a yes, Mr. Johnson, I see you.
If you weren't like using the Object Explorer on the left to find the primary keys and the foreign keys, is there a command that you could run against the table that would tell you kind of all these fields that are required?
Yes, I am going to talk about that in just a second. And in that case, well, you go back to this code. But I can also see that in the graphical user interface. Are there commands you can run against the database? Yes, there are. They tend to vary from one SQL to another. So just in general, you would refer back to the creation script, which you would keep, and that would be part of the documentation of the database. there are commands that say show, show me all of that, and we're going to have a section on what we call the data dictionary, and so we're going to go in and find some constraints that have, find all the foreign key constraints, and yes, you can run commands against that. Now that tends to be platform specific. I'm trying to stay with pure SQL here.
Okay, thanks.
Mm. I'm going to I'll show you how to find all that stuff in the graphical user interface. There's nothing wrong with graphical user interfaces, by the way. So delete the child first. I cannot. Okay, I think we're done with this file. Anyway, I'm going to go ahead and assign this. You're going to put in some records into your owners and pets tables. It's fairly easy. I'm going to go ahead and assign that for next Friday, and now I'm going to, I guess I'll save that. Okay, I want you to go now, please go to Module 2. Somebody has sent me a message, but I'm not going to open it right here. Let's go home, modules, and I want to go to module 2, page 5. Module 2, page 5. You may have gotten here. You may have already gone through this. And we're going to create a database. That database is going to be named AP_DB. It says Azure user, SW Smith. I think the way we are set up now, you're not going to be able to create that as SW Smith. You will need to log in to connect as the system user. Let me take off this headset for a second. Okay, I will need to connect as the Windows user. So I always go Windows authentication. That's the simplest way to get my my system user. And notice that I already have one named AP_DB. That's fine. I'm going to demonstrate creating a new database. You're going to name your new database AP for accounts payable _DB. The owner is going to be you. That's me. Your owner is different. But I want the database name to be AP_DB. Do not click add. The add puts another row in here. Click OK. I'm going to click cancel because I already have it. We are not going to make this be the default database. The default database is Scratch. This is the accounts payable database. So this will be our database that we're going to be using to it's going to be our database, our main database. This demonstrates our production database. It has a bunch of different tables, and it's, well, first of all, we're going to go to Module 2, page 5. We have created the database. Okay. And you name it this and make it, and make yourself own it. Okay. There is a way that you, SW Smith, and I think I need to change this guy, SW Smith can have the authority to create databases. It's generally best if they do not. So go use the system administrator to create databases. I think when I wrote this, I had made you a database creator, and you can do that. I can show you how to do that, but I think that just adds a little complexity to it. So we will create the databases using the system admin, in other words, logging in as the Windows user. So name it, and make your user the owner of it. So I do need to go in and edit this page. I'll make a note to myself to do that. Download this file, create ap.sql. Save this to your flash drive, or save it someplace where it will be easily accessible. I mean that. It will be convenient, whether you use Notepad++ or not. That's fine. I don't care. Save this file, create ap_sql. The example database will be called swsmith_db. No. Okay. The database will be named APDB. Now I'm going to go back to this guy, and I have the file. I have downloaded the file and saved the file. Okay. The file has, what, let's say, how many rows in it? It has 863 rows in it. Some of them are commented out. Use AP_DB. Okay, do not use anything else, please. If you are working in the open lab, this is going to be important. When you are working in the open lab, you will log in as the administrator through Windows. That's the only way you can log in the open lab, as Windows. It's going to wipe everything out at night when it goes. It's under deep freeze, so it makes all the changes. You would have to run this file every time. Okay. And if you are working in the open lab, you will need to create the database. Now you can do it in the GUI. You can also create a database with SQL. I don't usually do it this way, but you can. So just if in your system at home, don't have that line on. You have already created this. This is when you are working in the open lab, you're going to have to create the database. Now choose the database, APDB, and boom, you're off to the races. You just make sure you don't have anything selected, and just execute. And in about 5 seconds or so, on a slow computer, it will run those 800 lines of code, and it will create all of these wonderful tables for you. You should get query executed successfully. At this time, you should go ahead and execute this query. Questions? But we're going to use it. Now, let's go over to our wonderful little Object Explorer, and let's take a look at him. And I forget who it was a minute ago asked me, how do you get information about it? The simplest way is using the graphical user interface. I don't have a problem using the GUI because there isn't a standard SQL query for this. They tend to be platform specific. Therefore, I'm just going to use this. Okay, I'm going to use this graphical user interface to look through it. What do I want? I want this guy right here, this database that says AP_DB. Let's drill down into him and take a look at what we have. Database diagrams, I'm going to come back to in a minute because he's really important and he gives me a lot of information. But the first thing I'm going to look at is the tables. So I can drop this down and look at these tables, and I see 1, 2, 3, 4, 5, 6, 7 tables. The two that will be the most important immediately will be the vendors table and the invoices table, okay? So one invoice can, let's see, vendors is the parent, invoices is the child. So one vendor has many invoices, 0 or more, and we'll see that to be true here in a minute. If I want to drill down into vendors and see what's there, I can take a look at him and I can find the columns. And if I go down into the columns, I see the names of the columns. Now, don't pay much attention to the nulls and not nulls here. That doesn't tell you much, because we created this with SQL, and these guys are saying, the only thing it knows is the primary key can't be null. It gives you this nice little key icon here and says that's not null. The rest of them can be null. Notice that they're varchar 50. That's because I got this one from the book and I rewrote it. I guess I should have written it. These aren't really allowed to be null. Notice that here, see this key, this dark key pointing that way, that's the primary key. Default account number is a foreign key. So that references something. And we have a way of finding out what it references. The rest of this stuff are just plain old vendor name, vendor address. Notice that everything in here starts with vendor, 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 vendor. Default terms ID is probably I think that's a foreign key. No, I think that isn't a foreign key. I left it not being one. So I've put some mistakes into it. So here's a foreign key. Now, if I want to find out a little bit more about it, I can look at the keys, and this shows me the 2 keys, and I can drill down into them. I can look at the constraints. I've got a whole bunch of constraints on there. By the way, here's a 0 length constraint. Somebody was asking me about that. And I can drill into each one of those. So if I open that up, check that the length of vendor city is greater than 0. A little cryptic there, but okay. So anyway, these are all the constraints. I'm going to leave triggers, indexes alone, and I'm going to come back to database diagrams, definitely. If I want to see a little bit more about the vendors table, I can right-click it, and I'm going to say edit top 200 rows. Don't say select top 1,000 rows. Say edit top 200 rows. That's kind of nicer, because that gives it to me now in a table. And by the way, I have full ability to change these data. So if I don't like the city somebody lives in, if I don't like you, I'll send you to Lawton, Oklahoma or something like that. So I have full ability to change data. I can add rows of data here. This is not a class about changing data using the GUI. I'm just pointing out that if I want to see what is in the table easily and have a way that I can scroll through it and look at it, it's a little bit easier than doing SQL. Now, this class is about using SQL. You don't always have a graphical user interface. It's nice when you do, but I can delete rows, I can add rows, I can change data here. We are not going to do that, but sometimes it's nice to be able to see what's in the table quickly. And the way I see what's in there quickly is I select the table name, and I just say, select the table, and I say, edit top 200 rows, and I see the terms table. So I see what's in there. Sometimes that'll be handy. I'm not going to do the database diagrams right now, but we will get to them. Questions on this? I know it's kind of a double load of buckshot here all of a sudden. You can drive around in here. If you trash your tables, not if, but when you trash your tables, as you probably will if you are running around here, guess what you have? You have the create AP underscore SQL. Create AP doesn't care whether the tables exist or not. If the tables exist, it just wipes them out and it sets them back to their default state. So if you go back and you run create ap.sql, that create statement, that table creation script, it takes you 3 or 4 seconds and your tables are all put back the way they were when they were before you got them, like however they are now. So if you delete something and you shouldn't have done it, well, okay, just go run your script again and everything's fine. It won't always be that way in a database, but because you have that script, that 800-line script, you're pretty much free. You don't have to worry about changing stuff. You're free to change anything you want and see, just get a feel for it. Right now we are working in something that's a little bit like working in Access. So if we did the whole class and we taught the whole class using this, we would be teaching essentially Access, because SQL Server, all it is Access is big brother. And I can create the table. I can drive my GUI around. I can create a new table. I can create the foreign keys and stuff like that. But that isn't what this class is about. Okay. Module 5. Oh, golly, we're at 10:50. It's about break time. Anybody want to take a short break? I do. I need to run to the bathroom, and so I'm going to pause my recording, and somebody's going to ask me, but when I come back, somebody say, hey, Dr. Smith, did you turn the recording back on? Okay, so somebody asked me that. I'm going to pause the recording now. Okay, I have turned the recorder back on after our break, and what was I? We are now beginning with Module 5. So let's see. Modules, if to catch up where we are, I went to Module 2 to download something. Module 5, we are in the select from where statement, so Chapter 3. Now we're coming back. Module 3 and 4, we reached way ahead in this stuff just to pick up the create table and the insert. And in my opinion, we need to do that before we start talking about manipulating the data. Anyway, we're coming back now. Now we're going to go through it in pretty much lockstep order. We're going to follow the textbook a lot more closely. So we are in Chapter 3. And this is the select from where, also known as the SFW query. I have some pages in here where I talk about the SQL and database, talk about how SQL is different. It is a different animal than C++ or Java. I'll let you read this. I'm not going to go into this a whole lot. Okay, we have the SFW query. From now on, all discussion will center on what I call the AP schema we created in Module 3. In other words, AP underscore DB. From now on, we will always have this. If you have another database at the beginning of your script, I am not going to be happy. You need to have it named AP underscore DB, because I'm going to know it immediately, because as soon as I try to run it, my code is going to barf on my machine. So mine is named APDB. Yours has to be named AP underscore DB. Simplest form, select statement, and the select statement is the most common SQL statement. Well, create table is a SQL statement, but this is SQL commands break into 2 major pieces, what we call the data definition language, and that is create stuff. So create tables, insert data, push data into the creating tables, creating things. There's other things we create besides tables, and we're going to see them later. I'm not going to go into them right now, but one example is creating tables. So defining the data, creating the tables. Then the other piece of SQL is what we call the data manipulation language, and that would be changing the data, updating and inserting. Now selecting, we have those things that let us retrieve data from the database. And the select from where statement is the most common one, because the select from where goes to the database and gives us back data. Just SQL alone is not very useful. Oh, it's about as useful as the engine in your car. And you say, well, the engine in my car is pretty darn useful if I want to go someplace. And I agree with you, it is useful. But just having an engine, if all I had sitting in my garage was a car's engine, it wouldn't be very useful to me most of the time. It's a great tool, I guess, but I need to have a car wrapped around it. So what we're studying right now is the engine, and this is your engine, the select from where statement. So select what fields from which table. All SQL statements should end with a semicolon. SQL Server is somewhat promiscuous about requiring it. SQL Server does not always require it. Most implications are very fussy about this. Most implementations are very fussy. Therefore, I am fussy about that. Even though SQL Server will let you get away without putting a semicolon. I won't. Copy and paste the following statement into a query window. What does that say? It says select vendor name, vendor city from vendors, and I believe I have that already in there. Vendor name, vendor city. Don't worry about my capitalization scheme. Well, look at it. I use what is called camel case. Other people feel differently about it. Some people like it, some don't. You typically begin with a lowercase, and after that, vendor, and then when it's 2 words, I capitalize the second one. Other ways of doing it, some people use underscores. I'm going to let you decide what you think looks the best. I would like for you to come to some kind of a convention that's different from just putting everything in uppercase. The usual convention that you find in SQL is that the reserved words, i.e. the ones that turn blue, are written in all uppercase. The others, the ones that I choose or that are chosen by the users, the identifiers, are written in a mix of uppercase, lowercase, or maybe just all lowercase. Maybe I don't know. What do you think about that one? If you chose to do it that way. They're not interchangeable. You have to choose one way and stick with it. Some people like this one. Some people like to do it this way. I'm going to support either way. I'll let you make your choice. There. I use this one. That's just, this is the Java convention, and the underscore is typically associated with C programmers tend to like that. I don't know why it changes. So if I execute this, I get 122 rows returned, and all of the, I can scroll through my data. You're free to execute that. Close that window. Now it's possible to rename these guys. So select vendor name as vendor NAME, and I put a $sign right there. The $sign doesn't mean anything except it's just, I don't know, I put it there. Vendor city as vendor space city. This is fine. Anytime you have a space in it, you use these, you have to put the square brackets around it. Some implementations use a double quote, but the square bracket is the typical way to do that. Okay, here's a caveat. I do not want you to do this, even though it will work. If you use the SQL server, will accept spaces in the field name. Now, if you want to see me throw a fit, just put spaces into your field names. Ooh! I'm just going to jump up and down and hold my breath until I turn purple if you put spaces in your field names. Now, this is a little bit different. This is a space in the alias. Okay, this is for the your end user to see. And I guess that's okay. If you want to put spaces, if you're renaming them and putting spaces in them, it's okay, I guess. There's no real reason to do it, but this one I see vendor name $, and in this one I see vendor space city. Ho hum. And the reason, oops, I goofed that one up, didn't I? Undo, where's my undo? Somewhere up here. There. The reason I'm kind of poo-pooing this idea is because SQL, the output of SQL is very, very rarely sent to the end user. SQL is a very low-level language. SQL is the data pump. It's going up to another language. So it'll be retrieved, it'll be caught by that other language that I was talking about, the one that we're going to study next semester. From there, it'll go up to Visual Basic probably, and from there up to a web page. So it's got to go through a whole bunch of steps before it's going to get to the end user. This guy right there this guy's job is just give us the data. And I really don't care what these things look like. So very seldom will I ever worry about this. Okay. The where. Select from where. Select and from are the only two you have to have. In this case, you just get them all. This particular one says select vendor name, vendor city from vendors where the state is equal to CA. I believe that is California. Let's execute this. Well, other one, we got 122 rows. Let's see what we get with this one. I had 122 rows in the table, but 75. I can see down here at the bottom, I'm waving my mouse at it. I can see how many rows it is. By the way, don't pay a whole lot of attention to, sometimes I tell you how many rows I got. Lots of times I have changed the data since that. So if you're off by one or something, don't worry a whole lot about it. Just, yeah. Okay, so where the vendor state is equal to California. So in other words, select what fields, from what table or tables we're going to see, and this is the condition that we want. So equal, I also have, there's 6 of those guys, relational operators. I have equal, single equal means equal to. Yes, I know in this language, the single equal and the tends to equal, sometimes it means is equal to, sometimes it means assignment. As the language is developed, for example, in C, you'll find a double equal used to say is equal to. Single equal typically means assignment. SQL predates that. Okay, so let's see. In these guys, I can also put an or. I also have ands, so ands and ors. So select vendor state is DC or vendor state is PA. If I execute that, I get 6 rows from Washington, DC, Philadelphia, PA, wherever Fort Washington is. I guess that's in Pennsylvania. No, I didn't select the state. Okay. Here's an and. This one is selecting vendor name and vendor contact last name. And you can go over and look at that table and see what those things look like. from vendors. Vendor state is California, and the city is Fresno. When I look at Fresno and I end up with 41 vendors that live in Fresno, it might give you a clue where our publisher lives. Our publisher is from Fresno, California, the garden spot of the world. Okay. Any questions? Let's see. I have equal to, and let me see. Over here, I talk some. Go to the next. I am following along with this. A database is well, I wanted to find where I told you. I should have said greater than, less. Okay, here we go. We've inserted the equal to operator. We have equal to, greater than, less than. Notice this one, not equal to, not equal to. I call it the diamond inequality. That is the one that works in all SQL. So the official rules of SQL say that not equal to is that less than, greater than thing put together. However, because it got C was so ubiquitous, the exclamation point equal also works in most applications. I tend to like the diamond better, but this one can be used. Greater than or equal to, less than or equal to, and an or are there. Okay, database is unordered. However, the output of a select from where query just got ordered. So now it's picking up an order by vendor city. If you do not say, let's see. Okay, that's whatever. Mine's a little bit different from the example. Vendor name, vendor contact, last name, California and Fresno, and I want them ordered by vendor contact, last name, ascending ASC. ASC is the default. If you don't say, it will always be sorted in ascending order. Therefore, it's almost never, we almost never write ASC. We just say order by vendor contact last name, and it is in ascending order. It will be in all databases, so you really don't have to write that. There are a lot of things that you can skip. I'm a little fussy about it, but I don't worry. If you skip that one, if I say order ascending, then you can just skip it. If, on the other hand, you want them descending, so let's run this one ascending. I'm going to see my last names, and notice I see the A's and the B's and the C's and on up through them in ascending order. If I change it and I say make it descending, well, now I see them in descending order. So a database is not ordered. Well, it is ordered. It's just ordered. You see it any way you want to see it. You see them in any order you want to see them, and you see them named however you want to see them named. You see them in whatever order you want the fields in, however you want them, and you see the data sorted any way you like it sorted. Now, that's pretty easy. It's usually fairly simple. I'm probably going to assign this one for Friday. Here's one that gets a little tricky. Select vendor name. Now, if we went over there and looked at vendor phone in our Object Explorer in vendors, and so let me go edit the top 200 rows, and I look at vendor phone, where is it? Notice I see some nulls. There's a null, there's a null, there's a null. Some of those things are null, and I want to know about those guys. I want to, here we go. Select vendor name where vendor phone is equal to null. And so I'm going to execute this, and something strange is going to happen. I don't see any of them. But wait a minute, what are you talking about? I can go over here and I can look at it. There's a whole bunch of them there that are null. The vendor phones are null. Why am I not seeing any output? Well, let's go. How about this one? I'm going to select it where it's not equal to null then. I execute, and I still don't see any input. Now, that's kind of weird, because then it'd have to be either equal to null or not equal to null. And the answer to the question is nothing gives us lots of trouble. It doesn't make any sense to say equal to null. Equal to or not equal to means is the same thing as, and null is not a thing. Null is nothing. Let's see. Is my car newer than, older than, the same age as your car? And the answer is, well, what if I don't have a car? What if one of us, or both of us maybe, don't have a car? It doesn't make any sense to ask, is one newer than the other one? Is nothing, if you have nothing and I have nothing, do we have the same thing? And that's a contradiction there. So you cannot apply. Here's the rule. You cannot apply equal to, not equal to, greater than to if either side is nothing, null. Null does not equal null. Nothing is not equal to nothing. And here's the way we do this. If we want to select where it is equal to null, we have to use the is operator. So select vendor name, vendor contact, last name from vendors, where vendor phone is null. Yes, this one definitely is a test question. This is true in all of them. Notice that this one gives me 25 rows. I have 25 null phone numbers. I didn't put the phone numbers out because all I would have seen was null, 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 null. Is not null will give me the ones that are so if I say where vendor phone is less than some value, I will not get the nulls. So if I say, you know, show me all of the employees whose salary is less than $10 an hour, a employee with no salary will not appear in the output. Show me everyone whose birth date is before this date 21 years ago. If they don't have a birth date, they will not appear in the output. Questions on nulls? Distinct, the word distinct suppresses duplicates. If I, for example, if I say select distinct vendor state from vendors, if I just say select vendor state from vendors, I'm going to get all the vendor states. So if I just say select vendor state, I'm going to get 122 rows, I believe. Yes, 122 rows of these guys. If I put the distinct back in there, I will now get the I'll suppress duplicates, in other words. So I only see one entry for California. And A, B, C, D, E, F, G. I don't know why it's coming out ordered. It does appear to be ordered, doesn't it? Don't take that to the bank. I don't. We didn't say order by, so the fact it looks to me like they're all in order, doesn't it? But that is not something that you can count on happening. Right? We didn't order it, so they're not ordered. They just happen to be ordered. If you want them ordered, you have to say order by vendor state. If you want to make sure they're ordered. I think I'm out of my... Okay, he's unordered. Go here and see if I need to. Okay, there's our null table. So I talk about the nulls here. We're going to run into this topic again, minimum, maximum. So if I talk about the minimum or the maximum in a field, it's things can get strange. Distinct. The word unique has been depreciated. We don't use unique anymore. I don't know whether this version of SQL Server will even let you say select unique vendor state. We don't use that. Should not be used any longer. Next. Okay. I don't believe I got around to putting this one in. I was running out of time. This one is going to be important to us. So I'm going to pause here. I'll be wrapping up in about 15 or about 20 something minutes. I'll be wrapping up here. Pausing for any questions so far. This one is going to become important to us. I'm going to follow along with this, so I'm not going to make this into a file of its own. Let's see, so we can derive the new field, invoices table. So if you were to go look at the invoices table, and you're free to go take a look at it in the Object Explorer. If you were to look at it, you would look at the columns and get used to going here and grazing, looking at it. Notice that the invoice has a primary key, and it has a foreign key into the vendors. Vendor ID is a foreign key. So invoices, primary key, vendor ID is a foreign key. It also has an invoice number, date, invoice total, and this is money. Well, what's the difference between money and number? Money is just a number. It's a number that has 4 decimal places on it, because money is always calculated to 4 decimal places. That's just true throughout database. I don't know that the books makes it. Oops. Book doesn't make a big deal out of that, but money is just a number with 4 decimals. So payment total, another number with 4 decimals, credit total, and we're going to talk more about dates and times later. We're going to talk a lot more about stuff like that. So I'm glossing over a little bit of stuff here. Let's go back now to our Okay, so we have invoice total, payment total, and credit total. So the amount due would be the invoice total minus the payment total minus the quantity, payment total plus credit total. Notice that they're in parentheses, or I could have said minus and then minus here. This is going to be important because this guy's going to be used a lot. And I really don't want to store the amount due in my database if I can calculate that. So here's the way I would get the amount due. Copy him. Let's go back over. Paste. So this one's coming from invoices. So select the invoice number and invoice total minus payment total plus credit total. In other words, select this guy, this calculated, and name that amount due. Now, we'll come back to that naming it in just a minute. If I execute this, notice that I get the well, it doesn't show it with 4 decimal places. A lot of them are 0, and a lot of them are greater than 0. That's going to become important to us. Okay. Now, so notice he shows as amount due. If I put him in square brackets, I could. If I try to put a space in there, he's not going to work. Actually, well, I get a error there. I could have put that in quotes. You can skip the AS It is possible not to have as. If it doesn't find a comma between them, it assumes that it's going to have the word as between them. Please don't do that. In my opinion, I don't think you should do that. Now, what happens if you don't rename it? This is a comment, by the way. I'm going to comment out that line right there, and I'm going to execute this without renaming it. And notice that I get everything it does okay, but it just says no column name. It is not good to have an output that says no column name. You like always to have names on things. So we're going to give it the name as amount due. He's named. So now when I execute him, I see that this is a table. So the output of an SQL statement, let me stop here and stress something. The output of an SQL statement is a table. The output of an SQL statement is a table. The table has to have a column name. Not allowed to have anonymous column names, or shouldn't have. That's really bad. So this is a table. The output of this statement, when it runs, it gives me back a table. This table only exists for a minute. I can cause that table to stay around. The output of an SQL query is a table. In Access, when you create an SQL query, you save it, and therefore the output is there for you to use later. This one, in real SQL, that doesn't happen unless you make it happen. Questions?
Can you order by that amount due, since it's a calculation?
Well, I'm just about to. Yes,
Okay.
Absolutely you can. You can order by the amount due. I want to do one other thing first. I'm not interested in these zeros. So since the order by is the last one, I'm going to do the where next. Where amount due is greater than 0. Now this one's going to barf. In other words, I cannot use amount due in the where clause. If I try to execute this, it's going to go or however it goes, and it's saying invalid column name amount due, and I say, well, what the heck are you talking about? I can see you right there. And the reason is because that hasn't happened yet. So if I want to ask that, I have to copy this, and I don't like doing this, but this is just the way it goes. I have to copy this, and instead of amount due, I have to put that calculation back in there. And yes, it's nice when I get to having a variable and I can set a variable and work with it. Now, this will run. And I get the ones, I get 12 rows. Okay. So I cannot use this alias, this column alias, in the where line. But I can use it in the order by line. This will work just fine. Okay, so what's going on here? How come I can use it in this line, but I can't use it in the where line, even though the where line comes before the order by line? And the select line comes first, and well, that's not exactly true. It goes to the order of the evaluation of a select from where query. And let me go back. I believe I have that here. Where won't work, and it won't work in any SQL that I know of. And the reason for this is, let's see. So I'm talking about this right now. It would be correctly written, so I can order by the amount due, but I cannot have it in the where line. And here's the reason for it. The reason is explained in the sequence of evaluation. The first thing that happens in a select from where query, the from line is evaluated first. It goes out and figures out the table. Then it figures out the where. What rows do I want? So first finds the table, then it figures out which rows to pick up. Then the third thing that happens, it figures out which fields to show. Okay, now this guy has come into existence. On the third thing that has happened, this guy has come into existence. Therefore, I can use that in the fourth line of evaluation. So I can use this amount due alias in the order by, but I cannot use it in the where line. Does that make any sense at all to you? It does if you think about it.
It does.
Yeah. That gives students some trouble. Now, if you don't want to remember that, you can always just say, okay, I can't use that amount due. For now. There'll come a time later when we will use it. Right now, I'm just mentioning it a little bit. The database products differ in their behavior if you do not create an alias. SQL Server just simply says no name. Others do things differently. Others will give it a name. Bottom line, always give it a name. It is possible, and you will see programmers that will drop this out. So programmers will write it like this. In other words, they'll drop the as, and you'll find that it works just perfectly groovy. It gets its name and everything. It doesn't change anything. And if you want to do that, well, when you're out of this class, you do it. And there's nothing wrong with it that I can see, except I just need to have a standard way that I teach standard SQL. Later, and I'm going to point out several places that you can skimp on the syntax. I don't see anything wrong with it, but I don't want you to do it in the class. So
It does make it hard to read when you do it.
I think so. The comma goes between them, but if there's no comma between them, the SQL interpreter just assumes that you're renaming it. And I think it's a I remember the first class I took in SQL back, I don't know, decades ago. The teacher just did it that way. In fact, it was taught with no as in there. But I think it's important to teach the as, and then later, as you figure out what you can drop out, you'll what you do when you are out in the industry yourself is okay. A wrap up. This is just kind of a review of it, and string expressions. Page 94 and 95 will basically the string expressions are, you'll put a are in single quotes. Just remember that. Use single quotes. Arithmetic expressions run just like they do in every other programming language. Page 98 and 99, I'm not going to cover that, so this document will expand minor topics in the text reference. We're going to leave some of these things that are just kind of mentioned in passing. I don't want to go into functions right now because that's the chapter 9. 100, 101, distinct. Ah, yes, my favorite, the top clause. It's worth reading about the top clause. The top, okay, select the top. Oh, let me go back and use it once here. Let's see, how many did I have here? Oh, select top 10 vendor name. Okay, so let's see if I got that right. I almost never use this. And it gave me 10 rows. So give me the top 10 rows. Okay. What's wrong with that? Nothing's wrong with the output. I mean, it's the top 10 rows. Why don't I like top 10? It's in SQL. So you don't really care whether I like it or not. It's there. Okay, here's why I don't like it, because we are taking the data by position. And I told you that data would be accessed by content only. Although in this case, it is accessing the data by position. So even if you did not have it ordered by, even if you just said, let's cut that out. If it's a nice thing, I can just execute a piece of it and not execute the last one. If I took it like that, they're not ordered, but I still got the top 10 in the output. I do not like top 10 because it accesses the data by position in the output and not by content. And I told you, I think I jumped up and down about talking about data are accessed by content only. And I gave you 3 rules. Remember those 3 rules? One of them was there are no duplicate records. No record may be duplicated in all fields. Well, if you don't have a primary key, you can duplicate it. That's almost never violated, though, because they will have primary keys and it does enforce it. But, you can do a table without a primary key. You just don't put one. I don't know that I'm going to call it a database table, but hey, let's see, data are accessed by content only, but here is an example of with top 10 where it doesn't. And then the other one is a field has exactly one value, and we're going to see that we can go in and I can have a first name, last name, and I can just search on just the first name. Okay, so sometimes these are violated, but those are our general rules. Anyway, the top clause is seldom used by programmers because the output is usually going to a web interface for further rendering. We'll just let the web page handle everything. I'll usually handle that top clause later. Anyway. So there's some stuff in there that I have not covered. String expressions, arithmetic expressions are covered well. Using functions will be covered later. And the top clause, we'll talk more about the top clause. I'm saying that's worth reading because it's definitely there. Next is what? Next is your little quiz, okay. And next is the exercises. I'm going to go ahead and assign Chapter 3 exercises because the Module 5 exercises. Module 4 exercises are pretty easy, so we can stack them up. So they will be assigned for Friday. I will assign the Chapter 3 exercises. In other words, Module 5. I see a lot of you have already turned them in. And go back and take a look at them and make sure you've got the stuff that I've asked for in this guy. Questions?
I can't use select from where as the user, but I can as the Windows authentication. Do you know why that might be?
Let's see. Let me see if I can turn you up a little bit here. Okay, try that again. I turned up my headset.
I said I can't use select from where on the APDB as the user, but I can as Windows authentication.
This is because you created the database. You did not make your user the owner of it.
As far as I know, I did.
Well, that's a symptom of you didn't. Okay. Go back in as the if the symptom of that is that you didn't let me see if I can get us back there. The symptom of that is, let's see, if I connected as, am I connected? Okay, this database, I don't remember how you changed the user. I'm going to connect as with Windows authentication. And let's see, databases. Let's see, I'm going to right click and I'm going to go to properties. Let's see, rename. I think it's in properties. Somewhere in here, okay, here's the owner. So if you go to general and you look at the owner, I think you'll find that the owner isn't you.
I'm looking at it and it does say that it's me.
Okay, so and when you try to run the a query against it, it say, what is the error that you get?
Let me test it out real quick.
And it might be in those permissions too if you hadn't set those right.
If you just set if you created the database and set yourself as the owner, then the permissions should just go along just fine with it. Can you see if you go to your user, can you see the database in there? You should be able to just fine.
Yeah, I can.
Okay. Now, but you're saying that when you go to a new query and you say select, I'm just going to say asterisk, that says select everything from vendors, and I'll need to say this is just a test, select everything from vendors. So I'm going to say use AP_DB. Now let's test it. So I'm logged in as my SQL user, and I say use APDB execute. What happens?
It says that vendors is an invalid object name.
Yeah, but right now I just want you to highlight use AP_DB. Just execute that.
That one completes.
That one completes. So then when you go, when you execute this, do you get 122 rows?
Oh, this time it actually ran, but
okay, yeah. In that case, you probably did not have. You probably weren't selecting use APDB because APDB is not your default database. So if all I do is I say new query and I just say select everything from vendors, the thing of it is that AP, if well, okay, it's working. I might have mine set as the default, but yours is not set as the default. So if you just say vendors, it's not going to the AP database. You must say use AP_DB, which is why I set everybody's default to Scratch DB, because I did not want you set defaulting to the AP. This makes you have to select the database, and it is always required to say which database you're using, because you might have 10 of them in there.
Okay, thanks.
Yeah, if you put that use in there, it'll get it. Others? Well, I'm going to have some duties here in a few minutes. Go in and take somebody some ice water or something as she's waking up. Other questions? Well, we're going to wrap up here for today. Would you like to have a lab later on tonight, later on this evening?
I don't mind either way.
Okay, I'll tell you what. I'm going to go, I'll make an announcement. And I think what I'll do, I'll just tell you, I will come back on at, let's see, it's Friday. I don't know if I, let's say I conducted a lab session, 8 o'clock, 6 o'clock?
A little later than 6.
Later? Okay, I'll come on at 8 o'clock. I'll be on, you're not required to join. So I'll come on at 8 o'clock. I'll make an announcement on this, and I'll be troubleshooting any problems, any questions, anything like that. I'll come back on at 8, and you don't have to be there. I will record it and post it. But if I don't have any students, oh well, I don't. Okay. I'm going to go ahead and end this meeting and get this up and posted so that this will be available to you.
Okay.
If there are no further questions, I'm about to shut her down here. Anybody?
Nope. Thanks. Have a good weekend.
Okay. Okay. Hey, when somebody talks, can the rest of you hear the person?
I can.
Yeah.
Okay. So you guys hear each other. All right. Well, that's cool. I'll see you guys then later. So I'm going to stop the recording now.